whatever we have seen under this topic, that is properties of surface and solids, that is the name of the unit number 3. We have seen center of gravity. How do we find out the center of gravity for a particular shape? Say it's rectangle, triangle, whatever it is. So for your circle or semicircle, quadrant, etc., etc., all this, as I said, there are 15 or 16 set of formulas with these shapes, and its x and y values with the area. So that you have to remember, and every problem goes like that. The procedure what we have studied is same. You need to find out the area first, x value, y value, then go to the answers, clubbing together with the formulas. Then second topic, when you come for that, it goes for a different types of shapes. Instead of telling a circle, right? It goes for cylinder, it goes for a cone, it goes for something else. So the procedures are same. You have to remember the procedures, and the method of how to solve the procedure maintained is same. You have to remember the shape, its formulas. The no other go, otherwise you cannot solve a question. And the next topic comes for, under that, it's called moment of inertia. It will be given as second moment. Second moment is the name actually. Under this, it comes as moment of inertia. The meaning is, we have learned what is a moment. See, everything this we are talking about a force. Okay, a force is acting on a body, and how does a different parameters on that force, and what are the changes. So moment means moment of a force only. The meaning is moment of a force, right? So the moment what we studied, moment, the symbol is m, means the applied force F into perpendicular distance. Okay, hope I have repeated many times. You would have understood. Do not forget, moment means force into perpendicular distance. What I mean to say, you can consider any diagram, any sketch, any number of force. If you want to find out moment, you should know the magnitude of the force. First point, you need to have a origin point or the reference point and multiply the perpendicular distance from the origin point to the force where it is acting. So for example, I'll just consider one, a zigzag sketch. I'm just pointing, this point is my center point, O. Right? I'll draw your y line, this y axis line. I consider from this O point at a distance of, say, suppose x. This distance is x. I have a force F. Clear? My distance is x. I have a force F. How do I write moment for this? Moment means M is equal to, I'll write MO. MO, right? MO. That is moment about point O is the force F into what I said. Moment means perpendicular distance. What is perpendicular distance here? Force, direction of force is like this. So I need to have, if my force direction is like this, what is perpendicular meaning? 90 degrees. This should be my distance. If it is 1 millimeter, 0.5 millimeter, 10 millimeter, thousands of millimeters. But I require a distance which is perpendicular for the line of action. Right? We are very clear in the topic. Fine. So this is, x is a perpendicular distance. Direction of force is was vertical up. My origin point, that means my reference point is this O, the distance x. So it is F into x. Clear? Now this I can write is Fx. Fx is my answer, moment of this particular force F with respect to point O. Now, if I am multiplying this x value once again for this force, understand? Moment means force into perpendicular distance, this value is okay. Now, if I take again a moment of that body with respect to same point, by multiplying another x value in the same direction, which means this f into x or fx, again I am multiplying a distance, that is second time I am multiplying that value with the distance. Okay, this becomes f into x square, is it not? X into x is x square. This MO1, or if you want you can take moment about first line MO1 here, I will write again multiplying second time moment about origin second time MO2. This it becomes fx into x. Second time, this is first time, f into x, again multiplying. The second time I am multiplying for the same moment, it's called second moment. It is second moment of force and area. It is second moment of that particular area or that particular force. It is also known as moment of inertia or moment of inertia. Why should we study about this inertia is a big question mark. No, I am talking about this inertia, a new word I introduced. We have known what is the moment. I just told second time I am multiplying the same distance, particular distance. I am made it f into x was first basically like this. Again multiplying x the distance, I made it fx square, and I said the word moment of inertia. Inertia, purpose of studying this meaning of this inertia is the applied force to a body when a small negligible, I mean a not countable small change happens during that moment, that's called moment of inertia. A small negligible change happening when this moment is taking place. When the force is multiplied into particular distance, a small change happening from the previous point. Previously, due to the moment, one change was there. Force keep on changing. When you multiply, the distance varies, the force magnitude varies. And another small change because of this moment is called moment of inertia. That's clear. Again, under this you have different shapes and formula for this. And normally, this moment of inertia is indicated as mi. Okay, the symbol is it is moment m and inertia it will be I. And in the problems while solving, you need not write this m again. You are just indicating with the value of I. I means moment of inertia. It's not separately inertia, it's moment of inertia only. Right? So I is inertia. Then as in the previous problems what we solved, we are finding out area, then when we go for the x values, then we go for the y values. Finally we add up. If it is a different portions are clubbed together, we add up. If there is a cut portion, we are reducing it, or a negative value, we are reducing it. The same type of process is followed here. Only thing is there is a change of formula because now it is inertia. It is not previous area, it is inertia. Change of formula with this symbol I. I can say one more word. It shows Ixx. You will be always writing Ixx because Xx is a reference axis. For any body you take one XX axis and one YY axis. Based on that reference only we are solving any question. So Ixx will be one formula given in the book and Iyy another formula. Based on that you find out. The second step is finding out using moment of inertia or second moment of that area. Clear? So in this, under this topic, if we solve one or two questions, the procedure is same, the formula differs, and there is a slight change between the previous set of procedures and this procedures, because here the second time you are multiplying the distance or finding again a moment for the already force. Already we have found a moment. For that moment or for that force we are finding once more the moment. So that formulas we will see solving one question, one or two diagrams, right? Before we step into the next one problem and solving it, I have just written two sketches. The topic is again moment of inertia only. The symbol is I, and I have indicated the unit as millimeter power 4 or meter power 4 or centimeter power 4. The purpose of writing this is, engineering mechanics, I already told you, you write any solution or the answer, you should indicate the unit for that. If it is millimeter, it is millimeter, or centimeter, whatever it is. If you don't write an answer including the unit, it becomes senseless. That means you'll get 0. You don't get any marks for that. Here, why should I indicate separately? I didn't indicate anything before. Now I'm indicating because this power 4 is the meaning, because first the force multiplied into the distance, perpendicular distance, it becomes square. Okay? Once more you are multiplying the square, x square power 2. So x power 4 it is. Meaning is distance square is x power 4. The distance gets multiplied twice. That is why I have written the meaning, moment of inertia. We are going to solve a question. In that question, whatever the answer comes, the unit should be in terms of either it is given in millimeter, it's power 4, centimeter, power 4, meter, power 4. This is very important, and you should understand why you are writing power 4, because the distance gets multiplied twice. See, it's an area. Second moment of area. Second, again, once an area, what is the meaning of this square? Meter into meter, meter square is the area it is. Once again you multiply that distance, it becomes power 4. It is second moment of area. That's what the topic is. Okay? So kindly remember, you have to write the unit. And next thing is, I have just given 2 or 3 sketches here. Okay, there are say 7 or 10 sketches. I already told you. Now every topic you go through, center of gravity is the first part. You will have many sketches in that, and formulas will be there like this. And now under moment of inertia also you have square, circle, whatnot. Everything is there. So there also you have formulas. Now a rectangle is there. Shape is this. Indicated the xx. I have already told you your xx, yy, whatever it is called, a reference axis. Reference axis. Same thing. Okay, x and y direction you have reference axis. Based on that only you are finding out center of gravity. Or you can write centroidal axis. To find the centroid, so CG, center of gravity, centroidal axis. Right? So this xx and yy is given here. And formula for Ixx, that means for this particular body, if you want to find out the Ixx value, it is moment of inertia value for this xx alone. Formula is like this. For a rectangle, it is bh cube by 12. What is b here? Breadth. H is height divided by 12. Formula given, second formula. And yy, hb cube by 12. H is first, and cube is for the breadth, then 12. Then you compose square, the same procedure, diagram is given, xx value, yy value, where is center of gravity, formula is given. A power 4 by 12. A is square is one side, A into A. So A power 4 by 12. A power 4 by 12. Ixx and yy are same for this one. Some diagrams it may vary, some diagrams same. See the circle, you have the circle shape, Ixx is pi to the power 4 by 64. And yy is pi divided by 4 by 64. So like this you have different errors. Why I wrote this diagram is, you can just copy it from the book and understand. The Ixx has got a separate formula, or the moment of inertia of any body is being defined by 2 different theorems. Meaning is, for any shape, is a rectangle, triangle, whatever it is, we are considering a reference axis, I told. Right? The reference axis may be in 2 types. Either the reference axis may be parallel for our centroidal axis. The centroidal axis means for the particular body you have xx and yy. Is this sure? Yes. My reference point axis may be parallel for my xx body's axis, also parallel for my yy body's axis. I can take a reference somewhere here. My yy, say my rectangle is here and yy axis is here. I will take a reference axis somewhere in a different distance, which might have some x distance. It may be parallel for this y. or parallel for the x, or it may be perpendicular also. It's normal. Normal means perpendicular also. So there are two theorems to define this moment of inertia based on it is perpendicular, whether the reference axis is parallel to the central axis or it is perpendicular to the central axis. Right? I'll just show a small sketch on that. Now the first thing is called parallel axis theorem. Parallel axis, I write axis because two axis theorem. Okay, write IE. Okay, first, what is the meaning of this? Now we consider a small rectangle. For this rectangle, you obviously know that you have one x-axis and y-axis also, right? My reference line, to find out the moment, I have to multiply with what? With what? Force into perpendicular distance. So some distance I should have. The distance, from where I have to take distance? From some reference line. The reference line is, suppose this is my AB is my line. If AB is my reference line and the say the shape or the body is at some distance, say this distance I will take it as h, okay, or I will take it as h bar. It is to differentiate as per the given the different textbooks, the approach will be different, but the meaning is same. If my distance from or the distance of the center of gravity of this body from the reference line is known as h bar, the parallel axis theorem says the moment of inertia to find out this value, that is I'll write IAB, moment of inertia of this body with respect to the reference axis line AB. Okay, centroidal axis means x-axis and y-y for this particular body. This is a different reference axis line which is far away from this centroidal axis. You have to understand, because second moment of area it is. I told you it is force into perpendicular distance, again multiplied by distance. Is it not? So it is moment of inertia of this body with reference to the this axis, reference axis AB, is given as the moment of inertia of the body with reference to that particular axis xx, Ixx. Where is this value given? Here. If I go for a rectangle, my axis Ixx value is defined. Because every shape what I am going to solve a question, solve a problem, the particular formula is already given in terms of Ixx and Yy. It's very simple. We don't need to substitute the values and get the answer. This Ixx plus sum of the area of the particular body. Where is the area now? For rectangle, what is the formula for area? L into B. Triangle, you go half into B into H. A square, it is A into A square. Then circle as it is. Pi r square by. Pi r square is your area. Is it not? So that particular area of that body, for here it's rectangle, you take L into B. Body into this height. What is this height? Into h bar whole square. Can you get me? Parallel axis theorem. Meaning is parallel. A reference line which is parallel to the centroidal axis of the body, but which is at a different distance from the centroidal axis. Say the distance is h bar, right? That distance should be multiplied with the square of the distance, should be multiplied with the body's area. Rectangle means L into B, or triangle means whatever it is, plus, and it is summed up with, it is added with the Ixx value, moment of inertia of that particular xx value. Is clear? Then what will be the y value here? Again IAB, to find out the y, that is y axis, into the IYY. Clear? IY is given here. Just substituting this value, we will solve one problem in this, you will understand, right? Plus, then what will be here? A into again h bar square. See, I wrote this h bar value here. This is height. This is for, I'm talking about x value. What my y direction? This height is for x, from x to this distance. Meaning is the reference. Then what is my y? It will come in this direction. The center of axis will have some distance from here. Is it? For this body, center is here, and this direction, the center is here. So I will have h bar here. This value will come here for y. Is it clear? In the x direction, what is my height? Multiplied the square of the direction, height into, square of the height into area. Square of the height into area. Ixx and Iyy holds good as such. So the parallel axis theorem is one theorem. One more theorem called perpendicular axis theorem. Perpendicular, the name itself you can not differentiate. Axis theorem. This theorem is for the same rectangle. If I have, okay, I will have my xx axis here, my yy axis here, but there will be an axis called zz which is normal to the plane of that body, which means this will be in one plane, is it not? XY plane. I can draw a sketch either in XY plane or YZ plane or ZX plane. What is this one? X, Y, Z. Any plane I can draw the sketch. I can have a triangle, rectangle like this, I have a rectangle like this, and anywhere. Is it not? So I can also draw an axis which is towards this. The XX and YY is joining here. G. Okay. The ZZ will be like this. A ZZ axis is also possible, which say it is perpendicular for these lines, for the plane of this area. It's called perpendicular axis theorem. And solving your questions based on your syllabus, you are using the formulas mostly used for parallel axis theorem. This perpendicular is in a very less used. I can say it's very negligible. So there are two theorems used for finding the solutions of moment of inertia. One is parallel axis theorem and perpendicular axis. Right? And based on this, we are solving the problems. We'll see one problem and we see the difference how we solve it. And do not forget the Ixx, Iyy value for any sketch, any shape, whether it's a rectangle, triangle, circle, everything is been given. And the distance from the reference axis, the center of gravity of the particular body will be at some distance. Suppose if the reference axis is lying on this, you will have a distance is 0. You will not have. You have a problem like that also. It is not compulsory that everywhere you should have a different reference axis and the h bar holds good. It will not be. Some places h bar becomes 0. That we'll see how it is. If the value is prevails, you should multiply that value and take the answers. That's it. And area is area of the particular shape. Rectangle means L into B, triangle means half into B into H, circle means as such. It's clear? We'll see one problem. So before just jumping to the problem, these basics are very, very important. If you forget what is h bar, you will not get the answer. You should know what is an h bar is. H bar for xx is the distance from a reference axis to the center point of that body in the x direction, in this side. And h bar from the left hand side, if you take from the reference point line here and to the right side. That's okay. That we'll see in problem.